In the streaming world, when we talk about real-time streaming, two major things come into mind. You can guess it right: Apache Spark and Apache Flink. Interestingly, one of them has a true streaming, the other one doesn't. Apache Spark, while it does the job well, it does micro batching, so that really eliminates it in this race. Now that leaves Apache Flink. How do you work with Apache Flink? You have major two ways. The first one is writing your code from the scratch, compiling it, packaging it up, and shipping it to your cluster. The other way is leveraging an existing tool where the team has already taken and abstracted away all the core programming skills and stuff that you required in there, and focus only on the transformation logic that will be required. So all you need to do is connect to the source, connect to the sink, set up your pipeline, and insert your transformation logic in between. That's all you need to do. And interestingly, we'll be taking a look at these two streaming giants, which is Decodable and Apache Flink MSF. Now, these two will be compared, and we will see how easy it is to just connect to the source and destination and insert and focus on your transformation logic, as compared to having to write your Java files, get your Java files into your Apache Flink project, writing your custom streaming logic, face a lot of bugs, and eventually package everything and ship it to MSF, where you probably we're going to encounter some errors, and then you fix it again, repackage it again, and the cycle continues on and on until you get it right. And once you get it right, everything continues working as expected. Now, taking a quick look at the architecture, we are going to start with the high level, the one at the top here. So the devices at my house is going to be sending some data to Amazon Kinesis, and from Kinesis we're going to connect Decodable to it, and then Decodable is going to be sending this to some sink. Let's take a quick drill down look into what this means. In my house, I have a temperature sensor, and I have energy sensor and humidity sensor. Now these three devices are going to be sending data to my Kinesis stream, energy stream, or humidity stream. Now, mind you, this doesn't have to be only Kinesis. You can use Kafka or any other device or any other broker you want in this place, but I'm going to stick to Kinesis for now. Now the streaming continues, and we have Decodable here doing all the magic. Now, by the way, Decodable is built on the Dependencies and Apache Flink. That's why you see them here. Now with this, they connect to the temperature stream, energy stream, and humidity stream on Kinesis on AWS. From here, they can now sync automatically into any sync that is supported. About 40 plus sync is supported in their system. So, but let's stick to this 5. And we're going to take a look at the first 2, then maybe if you have enough time, the last 3 as well. So, but regardless, so this is how the architecture looks like for the first part of the system, which is the decodable part. Now, taking a second deep dive look, it's the same thing, but we are now going to be using Amazon MSF. Now, Amazon Managed Service for Apache Flink does the same thing, but in a little bit more challenging way. Now, looking at this, the same thing happens. Our sensors are going to be sending data into the Kinesis streams, and from here we're going to be connecting the MSF in this case directly into that, and then of course syncing into the rest of the sinks as we have it here. The two architectures looks fairly simple, with a drop-in replacement of Decodable in one and MSF in the other, but when it comes to the actual implementation, it looks a little bit more challenging on the AWS MSF end. So let's get started with the architecture implementation and see how we can facilitate the process end-to-end on Decodable, and we try to do the same on MSF. Let's get started with that and see how that looks like. So why don't you get started by creating a new project? I'll be creating a new Python project to quickly do the production of the data, and we can just go over to Decodables and start consuming data directly as it is. Going over to the coding section, I'm going to create a new project, and I'm using PyCharm, by the way, just in case you want to use the same. Or if you like, you can use your terminal or any other ID you like. So I'll be using PyCharm for this video. So in PyCharm, I'll be calling the app Flink Decodable MSF. Okay, so we're trying to do the Flink for Decodable as well as MSF. So yeah, very creative name. So I'll just create a welcome script for sample and be using Python 3.9 for that, and then creating that. So once that is done, the ID will start creating and bootstrapping the application or the project itself. So I'll just clear this up. So those are the 2 or 3 things that I need to do. Then I need to first increase the size of this to 20, so it's a little bit more legible and easy to read. So the next thing is to start with the code itself. But before we do that, let's get started with the installation first and ensure everything is working as expected. So which Python? Where is our Python running from? It has to be running from the venv. So please check. If you have it running from any other directory, then it might be tricky. But let's just make sure it's running from the venv environment. Okay. Now, once that is done, we know for sure this is running from here. So we just need to install the dependency. So dependencies we're going to be using is going to be pip install boto3. So we just install boto3 automatically. So we have access to AWS credentials, AWS CLI and all that. So by the way, if you're using Windows or any other operating systems aside from Mac or Unix system, you need to download your AWS CLI. I'm going to drop a link into in the description on how you can install AWS CLI on your Windows system or any other operating system for that matter. But in my system, I already have it installed, and I'll show you how to do that with the Mac. So I'll just go back here. Oh, by the way, just in case you need to do the installation, just in case you need to do that, I'll just go to google.com and then AWS CLI. So if you go to AWS CLI, you can see the install AWS CLI, and you see the documentation here for macOS, for Windows, and for Linux. So if you want to install it for Linux, you go for Linux. For macOS, you can use the macOS package to do the installation. It downloads it and you can just install it. Other alternatives is to use something like a Homebrew. I prefer Homebrew in my case. So in case you want that, you can do Homebrew AWS CLI. So you just Google search that and you see something like this in your Homebrew, and you just do brew install AWS CLI. As simple as that. Then you have AWS CLI installed. So if you do AWS version, so I'm using AWS CLI 2.17.9, and by default it runs Python 3.11 because that's what comes shipped and packaged with it. But yeah, I don't really need to worry about the Python version or whatever it is. So the major thing is the AWS CLI. Now, once this is done, another thing is to do AWS configure. So AWS configure, once you've installed it and it's working just fine, you need to do AWS configure. Now, this gives you access to the this gives you an opportunity to set up your AWS access key as well as your secret key as well. I just hope I have not tampered with it. Okay, good. So just once you set up your access key and the secret key, you're good to go. By the way, if you need to get the access key and the secret key, just make sure you have your application or your AWS account ready. There you go to security credentials, and you see in your security credentials, you see there's something like this here. In your access key, so you have a user. So this is the root user. By default, as best practice, you don't attach access key and the secret key to your root user. So you can go to your users here, and in one of the users here has security credentials in this tab, and in this security tab you see the you see the access key and the secret key, which is sitting here pretty nicely. So once you create an access key, for instance, you create it for something like a command line interface because you want to use it for AWS CLI, and just click on next and give it a name and create an access key. This gives you automatically an access key and a secret key that you can copy. So you can use this when you are setting your AWS configure. You can just set your access key here with this guy. I'm not doing that, and you do the second one with the secret key and you'll be good to go. I'll just delete this. Okay, yeah, I'll just delete the newly created one. I don't need it. So I'll just scroll down. This is the latest one. I'll just delete this, deactivate. deactivate it, and delete it. Okay, so that's just the way to go with the access key and the secret key. So once that is done, the next thing is to test whether it's working or not and all that. But by default, you can just do like AWS S3 LS. So if you do AWS S3 LS, this should list all the buckets you have in your AWS accounts. But if you don't see something like that, maybe you haven't created one, you're still good to go. But so far you don't have any error message or authentication errors, you're good to go in that end. Now AWS is configured and linked to our laptop, or my laptop, not our laptop. So it's linked to my laptop. Now I can easily just connect to AWS and provision resources and whatever it is that I want to do automatically via the API with the CLI agent. Good. Now with that said, the next thing we want to do now is to create a stream, because we're going to be creating some stream from our local system and shipping them to AWS stream. Now, before we go on to that, let's create a structure of how the data looks like and how we're going to be shipping it into AWS before we start creating the stream. Okay. Now, going back here, I'm going to just quickly have an entry point if the name equals to main by default. So you don't need this. This is just like for bootstrapping, whatever it is sake. So I'll just have this as main, and I'm going to be disabling my auto completion here for my copilot. Okay, so I'm going to just have a simple function here called main. So what I want to do is have 3 different configurations, which are the streams. I told you earlier in the architecture that I'm going to be having temperature stream, humidity stream, and energy stream that will be shipping data into AWS for me. So those 3 will be created in my config, and I'll be reading data from there. So I'm going to just have a simple something. So let's create a config. So I'll just touch config.json, and you can see my config JSON here. So what would the structure look like? I'll just have a simple JSON here. Good. Now I have the interval, I have the AWS region, and have my devices set up pretty nicely. So the next thing is to go into my main. Maybe I should just rename this to producer. So I'll just move main to producer.py. Okay. So I just changed that. Here I still have my main as it is. So let's have a function. I'll call this data generator. I'll just call this dev. Let's pass this for now. We're going to come back to this. So data generator, and I'll be passing a device to this. So we are generating data for a particular device. In this case, I'm going to be extracting the device ID. It's going to be the device and the ID. So potentially I'm copying the data from here, device type and the stream, device ID type and stream. Yeah. So device type is going to be getting data from there, the type, and then the final thing is the stream name, which is going to be the device stream. Good. Now these 3 guys is going to be extracted from me, and I'm going to have a generator. So this is a Python generator. It's a high-level function. So well, that's a bonus. So you have let's have a generate temperature data, right? Data. Okay. So I'm going to have a function that does the generation, and for the humidity. Wow, oh my god, that's so difficult to type. I'm going to be having a generate humidity data, and finally you're going to be having the energy. So we have generate energy data. All right, so these 3 will be automatically generated. And I'm going to have a simple generator function. I'm going to have a generator function. So what this does is just put in the generator and put in the device. Okay, so I get the device type. All right, device type. So generator gets the device type and try to generate a function with that. So we're going to take a pause on this, and so we now get the generate temperature data into the picture, and humidity as well as the energy data. So let's quickly get those guys into the picture. I have my dev generate temperature data. Yeah, good. And once this is done, I can save this and just reformat the code, and that's good. Good. All the scribbles should be gone. Now we have the generators here, and so the data that will be generated will be from there. So the next thing is to automatically generate this data. So we have a generator function that passes the device ID to return a JSON object, and we just need to do a quick loop into that and generate some data from there. So let's proceed and start generating some data from there. Now I just need to have a while loop here. So I just have a while true, and I'll just scroll this up. While true, then I have a try except. So yeah, so the exception is going to be whatever exception that is generated as E, and I'm going to be logging this login.error, and let's import login from here. Login, yeah. So I'm going to just have error generating data for device. What's the device ID? And what the error is E, right? And then we can just do a time.sleep. Now the time.sleep is going to just be from the config interval. So we just have maybe every second or whatever it is. Okay. So let's import config. Yeah. So I just import the config. Now, how do you import the config? I need to just scroll up here and let's import the config. So with open config.json. Okay, as config file, config file. Okay, I just have config equals to json.loads. I just load that into the guy and config. There's no need for that. Okay, json config.load. So it just import json and config file. Okay, yeah, load. Yeah, good. And I have config, so I can use the config here, right? That's my interval. And for the time guy, let's import this from dates time. Good. Let me see let's not import from dates time. Let's import from time. So import time. Simple as that. Good. Excellent. So this is interval, not interview. All right. So it looks like the exception is handled. So what do we want to do in the try when we are generating that? So we just want to have a simple generator here. So this data is going to be generator function, and we pass in the device ID that we want to generate. And once the data is generated, so let's print this. In fact, let's just login.info. We put in data here. Now we just need to do one final thing before we start doing all of the testing. Is the login configuration. So at the top here, I'll just have maybe set up login. Set up login here, and I'll be login basic config, and the level is going to be level for this is going to be login.info. Yeah, and the format just to make it a little bit fancy, it's going to be a little bit of we just need to do some formatting, string formatting here. We're going to have ASC time here. Just close this up and have adds to that. So that gets me the time, and the login level name is going to be the level name. So if it is info or debug or something like that, I get that as well as a string. And finally, I just need to get a message. All right. So I just have a percentage and the message as a string as well. So you get the level name, the ASC time, level name, and a message, and that's it. So that's what my login looks like. And here I'm doing the load configuration. Okay, finally. Yeah, I'll just reformat that. Good. All right. So now that yeah, let's take this for a spin and see what the data looks like. I'll just need in my main function, since we are passing 3 devices, 1, 2, 3. Since we are passing 3 devices into our generator function, we want to generate data for these 3 devices. So the first thing is to generate for each of the device ID that we're going to be using in this video. So I'm just going to have a thread created for that. that would be an array. I'll just put in the threads, and then for the device in the config devices, so this guy in these devices here, I just need to have a single, each of them running on separate threads. So I'll just have threading, and this is all going to be imported from threading, import threading. Good. And I just created a thread, and for this thread I'm going to have a target, which is the function that will be called when creating the thread. I'll call it data generator without the open and close brackets. And what arguments will be going into this? I'll be passing the device into that, and that means the device that is generated from here. Don't forget the comma is also important in this case. Okay, so thread.start. Okay, start the thread, and then I can append this to the list of threads. So append the thread and the thread. Yeah, so the threads get created, but they just need to start running. Well, even if they start running, we need to find a way to join these three threads together on the main thread, okay, which is the one that is running this application itself. So I'm just going to have for thread in threads, okay, for threads and threads, well, for thread in threads, not thread in thread. Yeah, you get it. Thread.join. So simple as that. That gets me my threads running, and I think everything seems to be working fine. Okay, now yeah, I think that's fine. I just have this guy not left unattended, so let's just clear this and Python producer.py. Let's see what the data looks like. Okay, let's stop this. Okay. Data is producing, and that looks really interesting. So we have energy sensor that has this data. The sensor is energy, and the value is this, and the unit is that. Good. And the device ID for the temperature is here, and the humidity is here as well. Perfecto. Good. Now everything is running in the background on separate threads. So we have 3 threads there for now. But if you have additional data you want to push to the threads, you can just push them and let them run independently while producing. And that's just to be like a simulation of what the data is going to look like by the time you have multiple devices. They won't be waiting for each other to produce data. So that means each of the data can produce independently into AWS Kinesis. Okay, now that is done, don't forget we installed Boto3 when we did pip install Boto3. Boto3 is already installed in our system, so let's bring in Boto3 into the picture. So we start producing into AWS Kinesis. Import Boto3. Now, so once this is done, let's create a function that helps us produce to Kinesis. We say dev send data to, maybe send to we know we're sending data, of course. So send to Kinesis. We need a Kinesis client that will be created, and we need a stream name where we are going to be producing to and what data we're going to be producing to that. All right. So those are the 3 things that we need. And whatever Kinesis client we create, this is going to be the one that would be sending data. We will be sending data into. Now here, I'll just minimize this. When we are sending data, instead of just logging here, I'm just going to delete this and just create my Kinesis client. So this is where the data is going to be originating from. Well, the connection to AWS will be done. Boto3.client, and this will be Kinesis. So I'll just grab Kinesis from the client from there and send to Kinesis. I'll be passing the Kinesis client, the stream name that we already extracted from the device here, and the data that is produced here. All right, and once that is done, I just do time.sleep, so I can sleep for like a config interval. Let's say every second, right? Interval. So so we are simulating a heartbeat at every single interval. We're producing data every second. Okay, good. And that's probably what that looks like. If you want to, you can reduce it to something like 0.5. But I'll just leave it at that for now. So now we're sending data to Kinesis. Okay, good. Now, finally, once the data is produced, let's just have a login.info here to just say we've sent data into Kinesis. I'll say data sent to Kinesis, stream of this stream name, and then we have our data that is sitting there pretty nicely. Okay, and if you like, you can just do something with this response, but I don't need to do anything with that. There's no stream that we're producing to, so we need to create a stream on AWS that we're going to be producing data into. All right, so simple way to do that is to go back here and search for Kinesis here, and in the Kinesis you can go here, and from Kinesis you will see the Amazon Kinesis. Because we don't have anything, let's create a data stream. So you can create a data stream here by default, and that's automatic by default. But I prefer to do things because we already have a link from my laptop to AWS. I can just have one liner that creates a data stream for me. And if you go back here, you will see that there's no data stream here, and if you try to go to the dashboard, you don't see anything. It's not able to go into that. So I just need to do AWS Kinesis, create stream, and let's start with the humidity stream. In this case, I just write this one liner, and this automatically creates data for me in the Kinesis dashboard. You can see that I have total data stream now, and the humidity stream is active and is ready to accept connection. So let's do the same for the temperature stream and do the same for energy stream. All right, so the 3 is created automatically now, and we have 3 streams here sitting pretty nicely. Perfecto. Now the 3 is fine, and let's try to run this and see what our producer looks like when it's sending data into that. Before you do that, you can see say found credentials in a shared credentials file of my AWS credentials. This is what happens when you do the AWS configure. It goes into this credentials location, and you can see the data is getting produced in there. Now let's go to temperature stream, for instance, and see what the data looks like on AWS. I'm going to go to the shard, which is the shard 0, and I'm going to be trimming horizon, and let's see what that looks like. Perfecto. Good. Now the data is coming here pretty nicely, and everything is set. Now let's now go to drumroll decodable. Now on decodable is where we now try to consume these, because they are running on Apache Flink and CDC for Dependencies. So that works just fine for me, and I can easily just relate to that. So let's go to that, and I'll just go to decodable.co, and I'll just quickly sign in. I think I already have that logged in, but if you haven't done that before, just create an account, and you go back here and create a new account. And if you want to create a new account, by default, if you don't have one account before, it takes you over here, but because I already have an account, it just takes me to the list of my accounts. So let's call this Infallible Bell, whatever it is, and give this a name. And whatever region that I want to have it here, it doesn't really matter. So you don't need to have it in the same region as your AWS, so it doesn't matter. So let's just leave it as US to West 2. And yeah, I'll create an account. So this is Infallible Bell. Yeah, so you can also create a team account. So if you want to have multiple team or a single developer, just like myself. And if you want to invite people into your team, you can just go to account management and add members here. I have only one member. I can do invite member. Tell me your email address and I'll invite you. So yeah, so once that is done, you have the landing page, which looks like this. It asks you to connect to a source or upload a Flink job. Now, the simple logic is here for decodable. You need to have a connection and you need to have a stream. Now, each of the connection you create is going to potentially create a stream, because it's listening for events from wherever you connect it to. Now, the pipeline is where you now make the magic happen. It's where you do some of the aggregations you're going to be needing, creating your streams, connecting to the streams from the pipeline, joining multiple streams together, and even writing to a sink. That's where the pipeline, so the connection of the source and the sink and the transformation in between makes up a pipeline. But for the source, you need to create a connection, and for the source, and for the sink, you need to create a connection as well. So let's see how that looks like by the time we start doing that. In our connection, by default, they have data gen envoy. I don't need this. Thank you very much, Decodable. I'll just delete this. All right, thank you. So I don't have anything. I'll just create my first connection. Now, the first connection is to my AWS. So, but if you look at the connections they have here, about 40 of them, or 40 plus, yeah. But I'll just click on the Kinesis that I'm more particular about. And in the source, what type of connection I'm creating is the source. I need a stream name. Let's start with this one first. We are still producing. Let's stop this. Thank you. All right. On AWS, if you go back here, I have 3 streams, right? So that means I'm going to be creating 3 connections here. All right. Now, for me to be able to automatically connect that, so let's start with the temperature. Energy stream is starting. So the stream name is energy stream. And in which region is it? I'm having this in North Virginia. That's US East 1. So US East 1. All right. Then the I am row. Now, this is one of the configuration that you need to do beforehand. You can do this just once, so you don't have to do it multiple times. You need to have an I am row that is going to allow Decodable to access all your resources on AWS. This gives you give Decodable access to connect and pull data from that. So going back here, I need to go to I am, and in my I am, so I need to just search for I am here and open that in a new tab. Now in my I am, I'm going to go to my rows, and in my rows I have a couple of them here. So I'm going to create a new row. Call this AWS service. Yeah. So the use case is Kinesis. So that's where I want to use it for. So I just create a trusted entity, which is Kinesis. So I'll be using Kinesis Analytics, not Firehose. I'll be using Analytics for this, and I'll create click on the next. So because of the activities that I'll be performing, so I'll need a couple of rows to be granted to this particular row, right? So the first one is going to be the Kinesis Analytics itself that I want to be working with, and also the Kinesis for the Kinesis administration. And if you like, of course, I'm going to be working with AWS as well, S3, I mean. So I'll just need the 3. So let's start with the Kinesis. So I will need the Kinesis Analytics full access, and I'll be needing Amazon Kinesis full access as well. And the final thing is S3 as well, because I'll be writing to S3 also. So I'll just click on next. The 3 will be automatically added. This 3 will be added to the row, and I'll create the row. And let's give it a name. So I'll call this Flink. No, I'll call this decodable access. Well, let's give it a creative name. That's very creative. Just create a row, right? Now this is creating a decodable row for me, and if you check this out, I have decodable access. Now, once the role is created, you need one final thing to do before Decodable can still access, because as of this time, this doesn't know what Decodable is, and it doesn't allow any external connection into that. So you need to grant this and trust whatever relationship, the connection that is coming from Decodable into your environments. Okay. So now go to the trust relationship. And in the trust relationship, we just need to edit this trust policy. This trust policy is the one that would now allow us to write or to grant decodable access to our account. So in this case, I have a principal as effect is allowed. The principal is coming from Kinesis Analytics only. So what I need to do is just change this up to AWS. So the principal is AWS, and I'm going to be having I am row. So I'm going to put in this in a bigger screen or something like that, just to show you how it looks like. ARN, then full column AWS, and full column. Let me just zoom this in a little bit. So ARN AWS, I am double column, and the 67129301597. So this is the decodable access. Okay. So for their principal. Okay. So this gives them access to this environment that I'm currently working. The condition is this. So I need to get the condition here, and the condition is string equals, and the STS external ID. I just need to put this here, STS external ID, and this looks like this. So whatever the external ID is, how do you get that? You need to go to your Decodable web console. I'll come back to this later. If you look at this, I have my infallible bell here, but underneath here I have infallible bell 440. I'll copy this and that's my STS external ID. Now, this is what the Decodable is going to be fronting with. Well, my account is going to be fronting with into this AWS principle to say, I have this external ID. Is this guy trusted to access some of these resources? Yes, it is. Let them in. If not, they get bounced from here. So yeah, the trust policy is done, and yeah, update the policy, and that looks like it is fine. So I'll just zoom out a little bit, and that's it. So all you now need to do is go back here and create a first connection. So click on the create first connection, and here you see Amazon Kinesis. Okay, so the source is going to be the stream name. So in this case, we're going to start with the energy stream. Okay, and it's still US East 1. Of course, you know where to get this. And then the I am role, so which is this decodable access. I'm just going to copy this one, okay, and paste it here. So once that is done, the JSON is the value format, and I'm going to click on next. Okay, so just wait for this to connect to Kinesis, and boom, it is. So now the connection name is going to be energy stream connection, and then next. So I'm just going to get the field so I can import them into that. So I just refresh this page, and I can see the latest data. So in energy stream, the data looks like this. I'll just click on that, then go into the data viewer, shard 0, latest. I'm just going to stream horizon and get the latest one there. So I just select this one and copy the JSON object here. Go back to the decodable and import schema, JSON schema. I'm just going to import the JSON sample, paste this in here and import. So if I import this is going to automatically populate this. So of course, the device ID and the sensor type in this case will be used as our primary key. So I'm just going to select not null from here, not null from here. So for the timestamp, you can also change this to timestamp, but I don't want to complicate things because of the UTC and ISO format that I have in there. So I have the value of float and the unit of string. So it's as simple as it is. Now the string not null is going to convert this to primary key. So if you look at the primary key fields here, so you have the device ID and sensor type that I've already added to that. Just in case you need to add another data type, just delete that and you see all the supported data types in here. So I'll just leave this back as string. Okay, just continue this. I'm going to be selecting the primary key because this is coming directly from AWS. So it is only when it gets into the system that we can now enforce the primary key. But the fields needs to be primary key at this point before you start importing your data. So I click on next, and this is going to be energy stream connection. Okay, I hope I didn't change I didn't give it a wrong name. Yeah, energy stream, good. Just want to confirm that. Yeah, energy stream. Yeah, it should be energy stream. That's the stream name. Yeah, good. So then the connection name is going to be energy stream connection. Okay, so create and start. Now with this, I have the ability to change to the medium or small. So I'm just going to be selecting the small version. So and of course this is self-explanatory. You have hundreds of events per second, and if you have thousands of events per second, you select the medium, and for the large you have to upgrade your account to do so. So I'll just leave it as small, and so once this is done, I'll just go back here, energy stream connection, and I'll clone this guy so to save time. So this is going to be the same thing but temperature. I think, is it temp or temperature? Just to confirm that. Yeah, temp stream. Yeah, temp stream. Okay, and then next this, and this is going to be temp stream as well. Then next, everything is as it is because the structure is pretty much the same thing. So I'm just going to be temp stream connection and remove this as well. You can add a description if you want. Just want to leave it at that. So I'll select small. Next, again, I'll clone this for the humidity as well. So clone this, and we have humidity stream. Okay, next. Yeah, new stream, humidity stream. Okay, so the same thing. Next, here, humidity stream clone. Yeah, just remove the clone, remove this as well, and create and start. Good. I'm just going to change this to start small as well and start. Now this automatically at this point is going to start this connection, so you can start pulling data in from Kinesis. But what we want to do is, by the time we create a connection, the streams are automatically created for that, because it's going to be a stream of events from Kinesis into a decodable connection stream. So yeah, so let's look at how that looks like. So if you go back here and go to the streams, you'll see that you have the humidity, temp, and energy stream. So which one has been started? Let's confirm that. In the connection, so we have the energy stream started. So let's check the energy connection. So if I click on this, you can see this. Yeah, you can see the preview of the data in here. So the data is coming in as we expect. These are the preview of that data, which is good. So the next one will be to check the next stream. So let's check humidity. Do we have any data yet? Probably still not starting. Yeah, it's still starting. So yeah, let's just continue with those ones. But of course, you can see how the stream looks like eventually. So yeah, so once we have this, the next thing we want to do is, if you can look at our architecture properly, we have the 3 streams coming in from Kinesis. We want to funnel them into Decodable, and that would be like the 3 goes into a single stream. Then from the single stream we do aggregation and stuff like that. So yeah, we just need to create a pipeline in this case. Create an SQL pipeline. So to create this, I'm just going to insert into, let's create a new pipeline called all devices stream. So sorry, we're creating a new stream from this from the existing streams. So we are going to be selecting so if you look at the energy stream, so I'm just going to be selecting everything. So I'll just say select stuff from energy stream, union all, select stuff from let's go to the next one, humidity stream, union all, select stuff from. So what we're just trying to do is aggregate them in unify them into a single stream. Okay, so energy, temperature, and humidity. Okay, good. So let's preview this. So I have these 3 guys here. You can do the preview from the earliest or the latest. So because we still have like the incoming stream coming in straight from Kinesis, so we can do the latest. But if you want to start from the beginning, you can always do the earliest. So it's going to try and pull data in from Kinesis from us. For us, you can see the temperature sensor and everything coming in here. So if you need to change anything at this point, you can easily just change those your query and fine tune it and make sure that everything is in the right shape that you wanted. So once that is done, the next thing is to go into the next one. So all devices stream is automatically created as the stream name. So it's going to infer this. So you can see the ID and the sensor type as not null. So those will be like potentially our primary keys, right? And here we're going to have all devices pipeline. So that's the name of the pipeline. Okay, and next is start from the small processing and start from the earliest. Okay, and that's it. So the pipeline is created. So we just need to have well, before we do that, we have 3 streams coming into a single stream. In this case, if you look at this guy, we have this energy, humidity, and temperature stream that is coming into a single stream called all devices pipeline. So from this guy, once this is started, we can go back one step. It's still starting. So once that is started, all the data should be going directly into a single pipeline. So we just wait a few seconds for this to be done, and then we continue. Okay, so the pipeline is started, and if you look at the pipeline here, you see something like this, and you can see the data that is being input from the metrics, and the output metrics is here. So it's inputting. These are the data coming in per second, and the total records that is pulled into the system, and the outputs, which is the current stream that we currently have here, right? You can see the preview. So you see the humidity, temperature, energy, and stuff like that. Yeah, so the data is coming in as expected. So the next thing we want to do now is we've aggregated everything into a single stream. Then we can now perform our queries and aggregation on top of that particular single stream. So let's do that. So we can have a new pipeline that is going to be aggregating automatically from all devices pipeline. So I'm just going to create a new pipeline here. And in this pipeline, the same thing we did before, just like we wrote our SQL scripts, it's the same thing we're going to be doing here, except that we are going to be grouping and aggregating and stuff like that in this pipeline. So let's do that. So we have insert into, so let's say devices count pipeline. All right, so we have all devices pipeline here, all devices stream, which has the device ID and the sensor type. So we can have select device ID and then the sensor type, right? And then we can average or count. This is count, right? So we can do count of value. So this is this value is a keyword, so you have to add a backticks around that. So I'm just going to have count value. Yeah, count value is fine. So from what all devices stream. So this is basic SQL. So we just have group by device ID and sensor type. Good. And that's fine. So let's see if this works from the start, and we can easily see if our query is fine or not. If it is, then we continue. If it is not, we have to fine-tune this and improve. But for now, let's see what that looks like. Yeah, so humidity is here. So it's pulling only humidity into the picture. But in the pipeline, I believe we have, let's start again. I just want to be sure we're not making any mistake. Yeah, so so it's picking temperature this time around. So the 3 is coming in. So obviously it's not picking everything, but each time you run it, it's still like aggregating other things. So we are sure that our query is fine and the output we expect is coming out. So we just continue this and just see what that looks like. So I'm just going to be primary key in this case will be the device ID and the sensor type. All right, so this will be like a compound keys in this case. So I'll just have a pipeline. So I'll say devices count pipeline. Okay, so what does it do? I'll leave it at that. Yeah, I'm just going to go back to the small earliest and start. All right, so device count pipeline is coming into the picture now. And if you look at the historical, if you look at the history of this pipeline, so it has is coming from one pipeline, which is this all devices pipeline that is connected to one outbound, which is the devices count. So it has all this pipeline into the picture, and they are outbounding into this particular guy. Okay, so yeah, if you want to see the SQL script, is here, and the snapshot, there's no snapshot for now. So we have this SQL here as we expect. So we'll just wait for this to start and we can continue. Okay, so the pipeline started running now, and it started picking data from all devices pipeline. So 18 records per second, and the total records that is picked is 1017. And here we have the data in the output, which is good. So the data is coming in as expected, and it's writing into a stream. So in this case, we have the humidity, temperature, and we are meant to see the energy as well. So which is the, I'm just going to rerun the preview. Energy should be, yeah, exactly. So energy should be coming in as well as expected. Good. So the 3 is coming in, and the next thing will be to now sync this into some output. So we're going to be selecting Postgres as our output destination. So for that to be done, we need to create a connection that will be connected to, that will be used to sync all this data into a Postgres sync. So let's do that. So while this is going on in the background, we just click create a new connection, and here we have a connection. I'm going to have Postgres. So in the Postgres queue, I have a sync. So I need a host and all the other credentials. So I have a neon console. Here we have a sample Postgres that was created for us online. So you need to have something like that. You can use the same, or you can connect to anything you like in this case. All right. So I'll just click on connect, show password. So I'll just copy the host name, and in the Decodable console, that's my host. 5432 is the default port, and the database name is the YouTube DB. Okay, YouTube DB, and the schema is public. Username is YouTube owner, and the password is add a new secret. I'm going to have my new secret is going to be Postgres password. Okay, and this, yeah, leave it at that. And the value, in this case, I'll just copy from here, copy this, and paste it in here. Set. Good. So yeah, that is encrypted, and I need to just click on next. Now this is going to create my Postgres connection. Now this is very important. There are two types of stream type you have in Decodable. One is change type, and the other one is append. Append is just like a Kafka, just append only. As you're producing, you just keep appending data into that. But change, you do aggregation on those ones. Okay. Now in this case, you cannot select both stream and append, change and append at the same time to sync into this using the same connection. So you have to group them. So in this case, all append streams can go into a single connection, and all change streams can go alongside with another connection. So let's do that. So in our append, we're just going to select all devices. We just want to write all of this. I don't need to write humidity and all this. If you want to, you can do that. But I'll just select all devices stream, and this is going to be writing to all devices. So in the destination table, I'm just going to all devices stream. Yeah, that's fine. And for the schema mismatch handling, so if you want it to fail, if it doesn't have the right schema, then you can select this about propagating new fields. And what this means is automatically creates the table for me if I don't have it before. So by clicking next, I'm going to have pg sync for append. Yeah, so this is append only pg sync. Okay, pg sync append, and I'll click on next. Go to small, earliest, and start. Okay, so with this, I have my all devices stream that is connected to Postgres on my Neon console. This is starting already. So this is going to be syncing data into my Postgres from all devices stream. So what that means is all the aggregated data from my all devices is going to be going into the Postgres. And this is for append only. So we just wait for this to be done, and we continue from here. Okay, so it's running now, and it's pulling data in and trying to sync data into console. So let's check this out. In the table section, do we have anything here? You can see all devices stream is automatically created here, and you can see them getting populated as expected. So you have the temperature, humidity, and if you check, we should see energy as well. Good, energy is also here. So the three is going in there pretty nicely. Now, so the next thing will be to go back here and have our the second part of the sync, which is the change sync. We need to create that, and we can now sync the rest of the pipelines into the picture. So we have the pipeline here. I have my count, so I need to create a new pipeline. I'm just going to have insert into devices average stream. Okay, and here I'm going to be doing the same thing that I did before. So so it's going to be select, let's go into the all devices, copy the primary keys here, devices, device ID, sensor type, and then average of the value. So in this case, I'll copy this, backticks here. So I'm going to have average value. Okay, average value is going to be going in there, and I'm going to have from where all devices stream, and group by the device ID and sensor type. Good, and save this, and so I just click on the earliest, and it can pick and preview the data already from the start. So we are now going to be writing the average stream into this device's average stream. So this is going to be a change. So this is the temperature, the average value is 22. Let's check again. Yeah, so it's still picking temperature, but what this means is our aggregation is fine, but the rest are going to be populated by the time the data gets into the average stream pipeline here. So I just click on next, and primary key is going to be the device ID and the sensor type. Okay, create the stream, and then next. So this is going to be the average devices average pipeline. All right, and create and start from the start, small, and then from the start. Okay, so the pipeline is started, and now we have the data coming in, about 3,497 records coming into the devices average, which is good. So if I go into the outbound, and you can see what the preview looks like. So this is the devices average pipeline. So let's run the preview and see what this looks like. So I have the humidity sensor coming in here. So let's run it again. So it's only humidity here, but of course we know that our query is fine. So we should see the 3 at the end of the day in the output section. So if you look at the streams again, and we have the devices average stream, and try to run the preview, hopefully we have the 3 coming into the picture now. All devices. Let's see, is our query correct, just to be double sure on that. Yeah, so we have the devices average. Yeah, so if we go into this and look at the SQL, so we have the device ID sensor type, so we know it's correct. So yeah, so that's good. So we have the preview, so we are able to preview the pipeline there. Now the next thing will be to have our connection to the same Postgres, this time around not writing the data as it is coming, but writing the change data into the stream. So let's go into the connection again and create a new one. So I'm just going to create a new connection to, well, I'll probably clone the existing one. So this is Postgres. I'll just clone this, clone the connection here. So the same connection credentials applies here as well. I'll just click on next. And here, so instead of the append, I'll just be selecting the change streams. So these 2 change streams, and this will be having devices count pipeline, devices average pipeline, and I'm going to be propagating the new fields. So I'm not going to be filling the pipeline. And you can of course view the schema and what this looks like. So this is going to look like average average value for the count. So let's see what the count looks like. So this is big int. It's okay, so it's not floats in that case. Good. So I just next this, and yeah, so this is PG sync. This will be change. All right, and I'll click on create and start, and small, earliest, and start. Okay, good. And we just wait for this to get started, and so it's starting now. It takes a few seconds to be done, and you can look at the stream mappings, what will be going on here. So we have the resource and the source stream. So we have this source stream as device count pipeline. This one is the devices average stream. So well, regardless, you get the point. So it could be the pipeline name. Just you can change the name to whatever you like, and you can view the schema as well. Okay, so we just wait for a few seconds for that to be done, and we're good to go. So this is starting. Okay, so it started now, and the data is coming in as expected. So you can see that it's running. So we have 233 records per second. Yeah, and it's reaching total records since last activation is 13,000 records. So if you look at here, and we just do a refresh here. Once we do a refresh, you see the devices average stream and devices count pipeline. The data will be aggregated each time the data comes in from Decodable into this table. The data is going to be automatically updated. So that's good. So we have this, and look at the pipeline. The pipeline is running devices count, devices average, and all devices pipeline. So mind you, so there's a constraint on Decodable, which is the 6th number of tasks. So if you want to increase the number of tasks, you just need to use the message. You reach out to any of the team members, and they can give you further information on how to increase the number of tasks you can use on Decodable. But as it is right now, you can easily just pick up from here, and you can see the data from the energy stream, the sensor, and the temperature streams here. And if you want to perform extra transformation on this, you can always do that. Maybe if you say once the average value clocks 50, send an alert or something like that. You can always listen on the pipeline and sync it to wherever it is you prefer. And in the case where you want to sync into like S3 or any other destination, so you just have to do is create a connection and map your existing pipeline to it, and the data gets written to that automatically. Now let's go over to AWS MSF and see what this looks like. As simple as this looks like on Decodable, just clicking a couple of buttons, mapping your streams to your creating your connections, creating your pipeline, and mapping your streams to the right pipeline. As simple as that sounds, it gets a little bit more complicated and complex when you are writing your raw script with Apache Flink. And by the time you package it and submit to MSF, it's another dynamics on its own. So let's see what that looks like in the real sense. So the first thing is to go to your IntelliJ IDEA. I'm using IntelliJ IDEA for that, and I'm going to be creating a new project. So I'll just create a new project. Yeah. So I'll be creating a new project just like before. I have Flink Decodable MSF, right? And it's going to be in the IDEA project. So now what I'm going to do is change this to Maven Central, and the archetype is going to be different. So I'm going to be changing the archetype to, it takes a few seconds for this to load actually. Yeah, so I'll just have Flink Quick Start Java, and this is using Scala version 2.11. So I'll just use this one, Quick Start Java. And 1.19 is the version, so I'll just have Flink Decodable MSF as the group ID, as the artifact ID, 100%. So that's fine. I'll just create this. Yeah. So once this is created, it takes a few seconds for the bootstrapping and the indexing and the download and all that to come into the picture, and everything gets bootstrapped. By the way, before you start this, you need to ensure Java is installed on your machine. So if you don't have it installed, you need to do that. So while this is bootstrapping, let's check what we have in the Java, what type of Java version I'm currently using. So if you do Java version, I'm using OpenJDK 11 as my configuration. Okay, so while this is going on, if you look at the build, so this is synchronized automatically, and the pom.xml is populated with the quick start to just get you started and everything running. Okay, if you go to Apache Flink, so you have the version 1.19. If you go to the downloads, you see the downloads here, 1.19.1. Currently on my system, I'm running 1.19.0, I believe. Yeah, so you can check that up by going into, so I have this into my 1.19.0 is my version. And so I have this running on my system. So I'm not sure if I have a cluster running. So if you have a cluster running, I need to first stop the cluster. So then I can show you how to configure this. So once you download this particular folder into your local system, you can extract it. Just show you how. Just download this. You can download this Scala version 2.12. I'm using 19.0, so it's pretty much the same, but the version is a little bit different. So that is getting downloaded. While that is downloading, so now once that is done, you need to extract that, and just you just use tar xzvf and then the Flink 1.19 version. So this is 1.19.1. To do the extraction. Once that is done, you see something like this. Okay, once you extract this, now in the configuration, I need to go to the config, so I show you what the configuration looks like. So in the I'll just do vi config.yaml. In the configuration, I'll just show you, I'll just expand this a little bit. Now in my configuration, everything is as it is, except that I changed one or two things here. So the first thing that I changed is the number of task slots, which is 20. By default, you only have maybe 2 or 4. So I just increased that to 20, and everything else is pretty much left as it is. Okay. So now you are in the root directory. You need to start it. So if you go to the bin directory and you go to here, you see the Flink console. You see the start cluster, stop cluster. So I prefer the start cluster because it just automatically starts all the required dependencies as well. So I just start the cluster.sh, and this is going to start the Flink cluster on your machine. And if you go to localhost, once that is started, localhost 8081, and you see the Flink dashboard coming up, and you can see the task slot you have, the number of task manager, the running jobs, the completed ones, the task manager, the job manager, and if you want to submit a job, you'll do it there. Okay, good. So now the configuration of Apache Flink is done. The next thing is to write the same code that we are going to be working with on Decodable, connecting to the source and writing to the sink as well. Okay. So yeah, if you look at the architecture so far, this is taken care of. So we did this with Postgres, S3 Sync. You can do with Apache Hoodie, Delta, and Elasticsearch as well. I'll just leave those because we still need to cover the MSF as well. Okay, now going back here, so let's start with the getting data from Kinesis, and from the Kinesis stream with this guy. Well, we can locally, this is Apache Flink locally. By the time you get to AWS, it changes to managed service for Apache Flink. Good. Now, once this is done, our setup is ready, and we are able to connect automatically to this guy for submission and all that. Now in the source, we have our Java here and all that. So the first thing we want to do is get in our application properties, so which is where more like the secret keys and all the keys that we're going to be using in the app is going to be sitting in. So yeah, so coming back here in the resources, I need to create a new one and call this application.properties. Okay. All right, so application properties. So I need to get in the a couple of things. So the first thing I need to get into the picture is the JDBC URL for our Postgres. Then we get in our Kinesis as well. So everything just comes into this application property. So we don't have to use this connection string in our code as it is. So let's go back into the code. In this guy, I just go to Neon. In the Neon console, overview, I'll just copy this connect, and I'll copy this connection string. So I'll just change the connection string and change it to Java, and I'll just copy this, show the password and copy this. Okay, and I'll paste it here as my JDBC URL. So I'll just call this jdbc.url equals to this. Good. Now the next thing is to get in the our Kinesis string and all that. But what region are we running in? Region, I'll just stop my completion. Region is going to be US East 1. US East 1. Good. Now, what's my stream initial position? Stream initial position, where I want to get the streaming from. I'm going to start from stream horizon every time. Okay, so you can start with the latest if you like, but I'll just start with the stream horizon. Then for the stream names, I'm just going to have Kinesis temp stream name as my temp underscore stream. We have the same thing for humidity, Kinesis humidity stream name. It's going to be humidity underscore stream. Then Kinesis energy stream name, it's going to be energy underscore stream. Good. Now this thing is taken care of. Now we have our streams, the initial position, AWS region, and the JDBC as our properties. So don't forget, these particular keys will be used in the rest of the code. Now let's go back into the code. you need to get in the dependencies right. Some of the dependencies we are going to be using. So there are two ways. We can always import the dependencies on the go as we need them, but a couple of them will be a couple of those dependencies will have to be installed initially to keep the show going. All right. So in my pom.xml, I need to get in my JDBC for the Postgres. So you can go into the dependency section here. Yeah, just below the last dependency here. So you can just get in org.postgres. Yeah, so this gives you the latest Postgres version, which is 42.7. So this gives you the access to that. And then you need to get in the Flink connector for JDBC. So I'll just get in org.apache.flink and Flink connector JDBC. This guy is what I need. And this gives me 3.20.19. Don't forget the version, whatever version you are running is very important. So I'm running 1.19. That's very important. Then the next two things that I need right now is the, well, maybe three things. I need the org.apache.hadoop, and I need the Hadoop common. So I'll bring this in, Hadoop common. Yeah. And I need the org.apache.hadoop AWS. I need this guy as well. And finally, I need one other thing, which is the S3FS. Okay, org.apache.flink S3FS Hadoop for 19.1, isn't it? S3FS Hadoop. Yeah, so there's difference between the Presto and the Hadoop because of the connection. So if you're using Presto connection, if you want to use Presto connection, you have to change your JDBC URL and probably the class that you're using to Presto. But by default, Hadoop just supports it out of the box, so you don't have to do that by default. Yeah. Then the final thing is to connect to Kinesis. So I need the org.apache Flink Kinesis. So I'll just get in Kinesis. This gives me this Kinesis connector, and I think we can run with this. If you ask me, let me see if we have anything else. I think we need something for Kinesis analytics. Well, Kinesis analytics. Yeah, I'll just say pom.amazon AWS AWS Kinesis analytics for Flink. For the runtime, I'll use this one, 1.20. I think this is fine. We can just run with this. So if we need anything else, we can just bring them in on the fly. Maybe something just come to mind. The faster XML Jackson. We usually need that every now and then. So faster XML Jackson. I'll just get in the JSR 310 and the annotations. Where's the annotation? And then yeah, just com.faster XML Jackson. I'll get in the JSR 310. Yeah, this guy, data type JSR 310. I think that's pretty much it. Yeah, is there, do we have the call? We have the data type. I think there's data bind as well, right? Com.faster XML dot Jackson. Yeah, data bind. Yeah, I think that's all. I'll just, if I need anything else, I'll just pull them in. Just synchronize with Maven here, so it can load all the changes. Otherwise, you need to do Maven clean install to do the installation. So well, this is doing it already for me automatically. Yeah, good. So I'll just close this up. We come back to that if we need it at any point in time. Okay, now change this to, instead of data stream job, I'll just rename this. Maybe I can leave it as it is. Really, it doesn't really matter what it is. What matters is the code that goes into it. Okay. All right, so let's start with the first one. So the first thing is to configure our logger, which is what we'll be using to log our codes, private static finals logger. So bringing in the logger into the picture. It's going to be the log manager, and then we get the logger class, get logger, log manager dot get logger. Let's bring in logger here, SL4J, isn't it? Log.apache Yeah, log4j. I think I'll need to bring in log4j because I can't see it here. So let's bring in log4j into the pom.xml. I actually thought I did that. So let's do that. Pom.xml. Yeah, Apache login. Yeah, it's here. So yeah, I just need to get in the right class. I just want to be sure. So import the right class. Import org.apache.log org.import apache.login. If I can only type login, yeah, log4j.log manager, and I'll do the same for logger as well. Import org.apache.login.log4j.logger. We just have data stream job.class. Okay, and that sets up our log automatically. So yeah, that's taken care of. I just need to clear this up. Yeah, so we can start writing the actual code that will be sitting in there. So the first thing we want to do is set up our configuration. So the configuration we're going to be needing is config. We're going to have new configuration. Okay. So this is going to be coming from a class. Yeah, this should be configuration, isn't it? So let's import the class from Apache Flink configuration. Isn't it Apache Flink configuration? Yeah. All right, so the next thing we want to do is set some of the properties that our Apache Flink will be using. One of these properties, when something like a retry strategy, when it fails and now it recovers from the failure. This is not something most people really do, but I really prefer this. So that sometimes when you run the code and it fails, maybe the dependencies are not ready, like JDBC URL is not ready, or the Kinesis stream is deleted and it's being created, or something like that is happening. So once it retries, it recovers from the error. So we can just quickly set that. So let's set the recovery strategy. I'm going to have restart the set restart strategy options, and I'll just have my restart strategy is going to be fixed delay. So it's going to delay it for a few seconds and try again. Then we need to set how many times, or the delay attempts is going to be. Config.set, we have restart strategy options dot restart strategy fixed delay. So we have delay attempts of 5, which is this is the number of restart attempts. So by the way, number of restart attempts. So it only tries to restart 5 times. And what's the delay between, or the interval between each restart? So we need to have something like config.set, and we're going to be setting the restart strategy options, and I'm going to have restart delay restart strategy fixed delay, which is the number of seconds to delay this for. We have the duration of how many seconds. So let's say 10 seconds is fine. Yeah, and that's that. So this configuration will be used when setting up our configuration. So let's get the execution environment for this. So it sets up that automatically by the time the our execution environment is getting getting started. Now the next thing we want to do is set up or make sure that the system is a streaming environment. So env set runtime mode is going to be runtime execution mode, and it's going to be streaming. Runtime execution mode of streaming. Okay, streaming. All right. Now, once this is done, the next thing is to set some of the properties that will be used when creating and connecting to something like Kinesis. So because Kinesis just cannot connect directly with to Kinesis, we need to set in some properties as part of the connection credentials. So the first thing is to get in our input stream right. And once we get in our input stream, right, we need to read from this application.properties. So let's get in that properties. So we call this props, and this is going to be new properties. Okay, so let's get this in from so this is going to be gotten from Java util properties. So we're going to try to read the data from input stream. So let's call this input stream, excuse me, input stream. So this is going to be input, and this is going to be our data stream job. Data stream job, class name. So we just get a class loader. So once you get the class loader, we can get the resources with this application properties as a string, and we just get in application.properties. Okay, so what this means is we are able to connect to this in real time during stream processing, right? So if the input is equals to null, what do we want to do? We just want to do a login. So logger.log. So dot error. So let's just do it like a log. I'll prefer error. So the error is going to be like sorry, unable to find application.properties. So just in case the application properties does not exist. So, but if it exists, we just need to do like a props.load. So we just load that as the input. So the system recognizes all these properties that we set here. The system recognizes them at the AWS region, the Steam Horizon, JDBC URL, and stuff like that. So we can easily just refer to them in our code. Now for the catch part, which is the, of course, IO exception, so input and output exception. We just exception for that is going to be maybe logger.error. And we just put in the ex.print stack trace, right? Print stack trace. Maybe ex.message should be fine. Just get message. Good. Now we just get the message and log it. That's all. We don't want to do anything too crazy or too in this case. All right. So the next thing we want to do basically is to have some sort of deserialization from Kinesis. So all the data that is written into Kinesis, we need to read them into our Java code, and we'll be able to do some manipulations with it. So to do that, we need to have some entities here that will serve as our sensor. So let's call this sensor data, right? Now in this sensor data, this is where the data is going to be. We're going to bring in sensor data here. So we're going to bring that data from Lombok. So let's bring in, so if you don't have it, just add dependency for Lombok here, and just have all arguments constructor and then no arguments constructor. So that's the sensor data with the empty, something like this, sensor data, something like that is what goes on in there. So we have private string. What do we have? Device ID, if you can still recall, on our Kinesis string. So let's check that out. So here we have on temp stream, we have something like this, data viewer, into the shard that we have, trim horizon, and get records. So you have something like this, device ID, timestamp, sensor type, value, and unit, right? So device ID is here, private string, timestamp, private string, sensor type, private float, value, private string unit. Okay, private string unit. All right, so the final thing we need here, you can actually create a new object for this, which is going to be more like an entity for this particular one, but I don't want to. If you prefer to do that, you can do for the aggregations, so for the count and the average, it's just the value and the so it's just the device ID, sensor data, and the aggregate value. So in my case, I don't want to do something like that. Maybe I just need to create a new class here, a new package called entities. So I'll just put this here and do a refactor. Yes, refactor this so it changes the class. Okay, good. So in my entities, I have sensor data there. And if you prefer, you can just put it in sensor data aggregation, but I'll just public sensor. I'll just do sensor data, and I'll just put in the device ID, string device ID. Yeah, I'll just use the device ID here, and then the floating value. So that would be the aggregation that I want to do. So just to be like a getter and setter from here from the constructor. So device ID equals to device ID. This is pure Java 101, really, to be honest. This is the value equals to value. Okay. So I'll just save this up. All right. So once this is saved, the next thing we want to do now is go back to our code. Now we have the entity that we're going to be using to bring data in, but we still need some kind of deserialization. So, but before we go into the deserialization mode, let's create a connection to Kinesis and now bring in our deserializer from there. So now we go into the data stream job, and in data stream job, you have the Flink Kinesis consumer here. So let's bring that guy in. So we call this Flink Kinesis consumer. So we need to import this guy from Kinesis consumer here. I'm going to be bringing in the sensor data. So that's the data we're going to be deserializing into. So let's bring this guy in as well. We have sensor data already, isn't it? Yeah, so let's bring it in. Sensor data is imported. So we have let's start with the temperature source. So temp source equals to so we need to have a function because we're going to be reusing this multiple times, so it only makes sense. So let's get in the environment, the properties that we just loaded, and the name of the stream. So this is in this case application for the temp Kinesis temp stream, right? So let's create a function that helps us to connect to Kinesis. Okay, so because we're in the static main, so we just need to create a static function. Static so this is going to be Flink Kinesis consumer for the sensor data that we just created for the entity, and call this get Kinesis source and bring in the stream execution environment. Yeah, the env, right? And then we have the properties, which is the application properties. And finally, we need to get in the stream name. Okay, stream name. All right, this three is what we need to connect that. So I'll just minimize this. So if you don't forget, we have something like this. So we need to create a connection here. So let's get in our deserialization here. Deserialization schema. Yeah, this guy. Once we bring in our deserialization schema, we are deserializing into sensor data. We call this the serialization schema. Okay, so but we need to be able to identify our deserializer for the sensor data, which is what we need to create right now. So we have sensor data deserialization schema. Okay, so we need to create this guy. I'll call this in this package, I'll call this serializer, and in the serial file should be serializers, right? Yeah, properties, plural rather. I'll create a class. I'll call the name sensor deserialization schema. So yeah, sensor data hey, if only I can just type the right keyword, the serialization schema. Okay, all right, I didn't know I had that error. So yeah, in this class, this is where we're going to be writing our deserializer. So I'll be extending from extends abstract deserialization schema from Apache Flink common. Okay, so let's pass in our object here and sensor data here. So private static final. Maybe we want to log. Yeah, let's log this. Log serial version ID UID equals to 1M. So, well, this is just like for the serialization, really, just to identify for the UID. To be honest, we have the maybe I just import this and just implement all of this. Okay, implement the methods, open and deserialize object. Okay. So we have open, deserialize. So why do I have to deserialize? I just need one of them. I don't need this guy. Yeah. So for the open, the context is fine. So let's get in our object mapper from Jackson, the faster Jackson. So I don't know if there's any other serializer that you prefer, but for me, faster Jackson makes the dream work and gets the job done. So I'll just have transient for the transient object mapper from faster Jackson. Let's bring that in, not the AWS faster Jackson data bind. Just getting the object mapper from there, and this will be my object mapper. Okay, I prefer this to other deserializer, to be honest with you. So if you have any other mapper that works for you, you can do that. Or if you want to write your own JSON mapper, but there's no need for inventing the build if you know what you're doing and somebody did it well. So I have a builder here. So just quickly build this and register the module. So if you register the module, I'll just use the Java time module just in case we have some date deserialization to do. So this is going to be coming from the JSR 310, right? And that's why I needed to get this particular jar into my application as well. So I have the object mapper here, and I have the sensor data. So the logic for the serialization is just to return object mapper dot read value. So you just read the value as bytes, then sensor data class. So you just read this and deserialize it into that. As simple as that. There's no need to throw exception here, so it's fine. I think that's all we need to do here. I'll just copy this, remove this collector from here, copy this and go back to our code and paste it here. So that's the serializer in play. For the serialization schema is sensor data, right? So let's bring this guy in and import it. Sensor data, the serialization schema, isn't it? Yeah. Why can't it just import automatically? So we just import com.data mastery lab serializers.sensor data deserialization schema. Okay, so that fixed that for us. So let's return the object that is deserialized now. So we just need to have a connection. Oh, by the way, I almost forgot. Now the AWS configure that you did earlier, if you can still recall, will be used when submitting this Java code into our Flink cluster that we're submitting the jobs into. So what that means is the AWS configure is going to use the default chain that you have in your AWS configure, the default chain, the access key and the secret key to connect to Kinesis. So if you have a different profile, you might need to configure that, but I'm using the default profile for this configuration just in case you needed to know that as well. So have the Flink consumer. So I'm using the app properties here. So I'll get property. So property of the get property. So what property? The property from the stream name is what I need. Okay. So once I have that, I pass in the deserialization schema and then I pass in the app properties. Okay. And that's all I need to do here for the get Kinesis source. So this gives me my Kinesis source for the Kinesis temp stream. So I can get the data stream from here, and data stream from sensor data stream from sensor data. I can get it from here. This is temperature. Yeah, temperature data source, data stream, not source. It's data stream, because we are working with data stream. We can change anything to like you like to it, so it's just a variable name. So I'll just add the source. This is deprecated, but yeah, I haven't really looked at the documentation for this part, so just look at the way to add. So because of the deprecation, I'll just add this. It still works for me, so I'll just leave it at that. It's not too bad. Kinesis temperature source. So this would be my my source. Yeah, I can just duplicate this for energy and the humidity. So I'll just change this to humidity, and this will be Kinesis humidity. So if I go to the application properties, Kinesis humidity, and I'll paste it here as well. Humidity, and I'll change this to humidity data stream. Humidity data stream. So the next one is energy. I'll just change this to energy, and then copy the energy source from here and paste it here. And this will be energy source, and this also will change to energy source. Good. Now I have the source, and I've converted them to the stream. Now we can now start the manipulation, and we can also, of course, write it to the sink. So yeah, that's taken care of now. So what I want to do is just like I did in Decodable, where I had all the stream, I put them in a single stream. I can do the same actually here as well. So let's put everything in the same all sensor a single stream for that. So I have a data stream, and I'll put this inside the sensor data. By the way, if you look at this, so it's more like technically everything is coming in here. So we just handle this part. So the next thing is to just put them in the same stream, then we can funnel it into MSF or Apache Flink directly. So I have data streams, and that's all sensor values, and we can get in our temperature data stream. So for the temperature data stream, we just do a union here with the humidity data stream, another union again, union with the energy data stream. Okay, so yeah, the three works just fine. We just connected all of them into the same, and yeah, so that's all we need to do here. So the final thing is to have, well, maybe not the final, we need to have a connection to our JDBC, which is the Postgres. Yeah, the Postgres. So we connect with it to JDBC, right? So and we already have our URL, the JDBC URL. We just need to create a function that helps us to connect to that. So let's undo that as well. So just like we created our get Kinesis source, so let's create another function just above here. I'll call this public create table sync. I think it's best to create a what's the name, a class for this that helps us do this automatically. So I'll call this create another package called utils, and inside this utils I'm going to have yeah, maybe not in the utils, so let's just create it in the root class. I'll just create table sync. Yeah, since it's just one, so I'll just leave it at that. So I can just do like extends reach sync function for the sensor data. Yeah, and then I have my JDBC URL, and then the connection that I want to create. Connection. Yeah, JDBC URL and the connection. Right. So the reach sync function is what we're using. So I'm just going to create a class called public create table sync. Now in this create table sync, we just pass in the JDBC URL, and we should be good to go. Now here we just create the properties, for the props. By the way, these properties we're creating is from java.util.properties. Yeah, so this properties is for connection to, just like we read from the application properties before. We just need to rerun this part again. I'll just paste this here. So it reads automatically. It helps us to read the application properties from here. So let me just copy the log as well and put it here. Yeah, so that will be create table sync class. Okay. All right, so that's fine. Our logger is taken care of. I'll just have this .jdbc URL equals to props.get property. I'll just get jdbc.url, just like we have in our application properties. Okay, so once you have the jdbc URL here, so the next thing is to have an override here. You can just override here. I think you can have an override methods. So what method are we trying to override here? I think it's the open. Yeah, open here. So I'll just override the open. So I just press the command N, or you can just maybe right click or something like that to do the overriding. Okay. So for here, it was an exception. So open parameters. So for the connection, we just establish the connection here and get in our driver manager .get connection for the JDBC URL. Then we just have a function that gets created once the driver manager is established, called the create table if not exist. And yeah, so this is the table we need to create. So let's create this method, and this is going to be throwing throws SQL exception. Yeah, imports the class. Okay, now so this is where we're going to be writing our SQL script that we want to use to create the tables if it doesn't exist. Now the reason why we're doing this in the stream is because we don't want to manually, just like on Decodable, we don't want to manually go there and start creating the tables by ourselves. So we can actually do the creation automatically here. So I'm just going to have a string create table SQL. It's going to be create table if not exist. Let's call this sensor data MSF, right? And we just get in the ID and other details that is required. Yeah, so far our SQL table is fine, SQL script is fine. We just have our statement. Okay, statement. Yeah, so let's import that from SQL. Import java.sql. So you just get a statement equals to connection dot create statement. Okay. And once that is done, we just do statement execute. And we can just execute the create table SQL statement. Good. And that's all we need to do to get the sensor data MSF created. So we need to do the same for the average value per sensor. I'll just do copy paste of that and change this to average value per sensor, count per sensor as well. Yeah, just copy this into the same block. So into this same block, and we're good to go. So that's taken care of. So the last thing is the invoke. We just need to override the invoke, override the invoke and the close. So close and the invoke. So those two we need to override. So if the connection still exists, connection is not equals to null, then connection dot close. But if that is done, once the close is done, for the invoke, I think we can probably move this up here. Yeah, so you invoke before close. It doesn't matter the order, just find it more chronological. So there's really nothing to do here, to be honest. Nothing here, nothing to do here. So this doesn't really mean anything. I'll just put it as it is here. Now going back to the code that we had here, so we're trying to invoke the data here with the creation of the tables. All right, so to do that, we just need to have create table sync, create table sync, and we have the object here as new create table sync, and we just pass in the properties dot get property of jdbc.url. All right, so now we can do this at the top. It doesn't matter where we did it, but I mean, yeah, just need to do it after the properties have been initialized, just somewhere here. Establish connection, let's just put it here. Establish connection to Postgres. Okay, so once you establish the connection to Postgres, the next thing is to effectively have a filter stream, more like the source where everything just come together and then get collated into a single stream or combined into a single stream. So that's the word. So we have the data stream of sensor data, and here we are going to have filtered stream equals to all sensor data, all sensor values here dot filter. So this is just like a simple map, just to put everything into the same bucket. Filter function, just bring that in. You can use a map function as well if you like. I'm just using the filter function for this. Sensor data, okay, and then this gets connected to the sensor data, and just map through sensor data dot get value. Value is greater than 0. We all know that this is going to always be greater than 0. So there's even though there's no point doing this exactly, but I just want everything to pass through the same point, so everything just gets collated into a single stream or combined into a single stream, then funneled into the subsequent transformations that we're going to be working with. That's all it is really. So let's write the filter stream. So if you prefer, we can do like a print at this point. Start printing things out and see what that looks like. I just don't want us to spend too much time doing all that. Yeah, so let's just proceed. We can always trust this is going to work. Yeah, so let's have for the start, the first one is the average values per sensor. So let's have average value per sensor type. Okay, so let's get in our data stream. So I'll just scroll this up a little bit, and I realized that I didn't increase this since, so I should just increase the font size a little bit. I actually just realized that, and I was thinking I wasn't actually thinking about the font size really. So I have the data stream here. I hope this is more legible. So I'm going to just have tuple 2 just to have for the two data that we're going to be having. So one is string and the other is float. one is for like the device ID, the other one is the aggregation of the values. So I'll just get in the tuple 2 into the picture. So once the tuple 2 comes in, so this is going to be average value stream. I'm just going to use the filtered stream going forward. I'm not going to be using all the sensor values, if that makes sense. So I'll just do a key by to do the aggregation by the sensor type. So sensor data, and I'll get sensor type, here. So once I have the key stream, I can have a window that I use to aggregate that. So let's use the tumbling window if you like. Tumbling window processing. Sorry, not tumbling windows. Tumbling processing. Yeah, tumbling processing time windows. I got it wrong. So I'm going to have of so duration dot minutes. So let's say every 1 minute is when the aggregation gets done. Yeah, any error so far? Yeah, no instance. Yeah, it's fine. We can always take this up. So let's do the aggregation now. Aggregate this. So we are aggregating on a new aggregate function. So we have the sensor data. So instead of tuple 2 here, I'll be using tuple 3, and I'll explain why I'm using tuple 3. So I have the string, I have the float, and I have the integer. Okay, so the integer is for the accumulation, and for the float is the actual value that we're trying to work with, and the final place where we're going to be having is going to be tuple 2. So we have the string and the float here. Okay, it will all make sense by the time we go into the accumulator type now, which is this guy we're working with. So I have the aggregate function here. Just comma this tuple 2, and yeah, so we just have an aggregate function here, which is the sensor type, a sensor data, and the three tuples here and the 2 tuples. So this is because we want to do the aggregation by the get sensor type rather. So just do like a override here, and just do tuple 3, and getting the string, the float, and the integer. This is for the accumulator, like I mentioned. Okay, so let's call this create accumulator. All right. So we just return a new tuple 3 object, tuple 3, which is something like this: 0 and 0, 0 and 0. Right. So this is a float, so it's 0f. Yeah. I think, yeah. So that's for accumulator. So for the accumulator, we need the add function as well. So so let's override the add, get results as, and the merge, so the 3. So for the add, we just return new tuple 3. So that will be the sensor data. So get sensor type, accumulator dot f1, the first value. Well, that will be the second, because f0 is the actual first one. So this would be the integer. So I'll just use this guy. Dot f1 plus sensor data dot get value as the actual value, and then put this as the third one, f2 plus 1. I think this is too long. Maybe I'll just change this to ACC just to make things shorter. All right. Okay, so I'll use this as ACC as well. Then maybe A for this guy. Okay, now for the result is just what results after adding. So what result does it spits out? So you just have a tuple 2. Eventually we have accumulator.f0, then accumulator.f1 divided by f2. So we're trying to get the average, so get a rolling average across the board. So the previous data plus the next one divided by the previous, the f2 is what we're trying to do here. So this is the integer that counts individual number of records that goes into this pipeline, this average value stream. So it counts individual number, and the second one is to add everything up and divide it by this second value. So it adds everything up here, which is what goes on here in the add 0. And for this f2, it divides it by the integer. So it's more like everything is into the float divided by the ACC f2 for the integer. Okay. Then the final thing is to merge eventually, which is the final results that we have. We're going to return new tuple 3, and this will be a.f0, a.f1 plus b.f1, a.f2, f2 plus b.f2. Okay, and I'll just change this is too long, change this to b. Okay, so we just have a and b for the two accumulator once it's merging them together. All right, so that's all we need to do to get the average. That's it. So we do the same for the addition for the count, except that it's not going to be as complex as this. I'll just maybe copy this and paste this here. So we only need for the count, we just need to change one or two things here. So we have the same filter stream. We're getting the same sensor type here, and we are processing in the same tumbling window of 1 minute as well. And so when we get the actual, just minimize this. So when we get the aggregates here, we are getting the aggregate for the tuple 3 here. No, we change this to tuple 2 because we just need the string and the integer. Really, we don't need the floats for the accumulation, for the summation here. So that's all we need to change here. Not integer, it's integer. So we need to remove the float from here, and this is going to be like this, and this is tuple 2, and this is tuple 2 as well for the create accumulator. That's taken care of. And here as well, this changes to tuple 2, remove the float, tuple 2, remove the float, tuple 2. And here when we're getting the sensor data, we just remove tuple 2, get the sensor data, accumulator f1 just plus 1. That's all we need to do here. Yeah, plus 1. Good. So it just keeps increasing the accumulator. That's all. Then for this guy, we have to put the float and the integer. That's all we need here, and we don't need the float anymore. Sorry, the string and the integer, not the float and the integer. And we just need to return the accumulator. This guy. Good. So this is tuple 2. Yeah, and the final thing is the last one, which is the merge. Well, yeah, so for the merge, yeah, we just need to remove the float as well. Let's see, remove the float. Maybe it would have been easier to just type everything from the scratch, but I think I'm too lazy to do that. Yeah, so I have this A1, AF1 and BF1. We don't need these parts for the BF2. Okay, so what are we returning here? So we are returning the count value stream, and here let me see, we are returning tuple 2, string and integer, and the sensor data for the aggregate function. So what's the error? So it says change the value to single operator string. No. So it says it's expecting, yeah, so the data stream is having string and float, and we are returning string and integer. So we just need to change this guy, float to integer. Yeah, good. So that's taken care of. So the count is fine, and yeah, the count is fine, and the average is fine as well. So we just need to do at this point is now to add the sync for the create table sync, and write all this as well to we need to write all of this to the JDBC. So let's have the filtered stream.add sync. Just have create table string into the picture here, and we just name it. Let's name it so it's easy to identify. We have JDBC sync for create table. Good. Now for the second one, for the all sensors, sync for all sensors data. So you just use the filtered string, just add sync. So we just use the JDBC sync. Yeah, from there we just bring in the sync function and just have an insert into sensor data, and getting the device ID, sensor type. What's the name again? Here we're using sensor data MSF, isn't it? Yeah, sensor data MSF. A sensor type, timestamp, value, and the unit, isn't it? Then the values, because we don't want to pass in actual values directly, we're using the prepare statement for that. Okay, 3, 4, and 5. Okay, we close this for the values. All right, so let's get in the JDBC prepare statement. JDBC statement, that's for prepare statement, and that's statement builder. We use this, yeah, so just pass in the prepare statement and the sensor data as the argument, sensor data. So we can use this as a prepare statement of set string in the parameter index of 1. So we send in sensor data dot device ID, get device ID. Yeah, we do the same for prepare statement for the second one. Maybe it's time for me to enable my completion. Set string for the second one as well, the type, the third one the timestamp, the fourth one is the sensor data get value, and the last one is get unit. Okay, so we just need to get in our JDBC execution parameters. So we just need to configuration. So we just need to get in our JDBC execution options builder. So this is just like with batch size of 1000, interval is 200, maximum retries. I think this is fine for me. And the final thing is the JDBC connection options. So I just get in the options builder. With the URL, I get a property for the JDBC.URL using this driver name, and that's it. So let's bring in this guy. So this is going to be JDBC connection options. Yeah. So the next thing is just to name this. So let's just name this JDBC sync for sensor data. I think let's call this all sensor data. Yeah. And then we do the same, sync for average values, sync for average value per sensor type. It's literally the same thing, except the values we are writing is average value per sensor, and we're writing into the sensor type average value. Is that what we're doing here? Yeah, average value, good. And then on conflict, on the sensor type, we need to do an update for the excluded. Yeah, Yeah, this is fine. So if there's any excluded value, when there's a conflict on the sensor type, just do an update when we are setting the updates. So what that means is when there's a conflict, there's an existing record, a new record is coming in. So instead of just overwriting that, the system excludes that, and we want to do an update on those excluded ones. So each time it's exclude, we want to keep updating the data in the table, and that's it really. Yeah, so the next one is for the count. Let's do the sync for the count. It's literally the same thing. I just leave that as it is, and that's all we need to do. So finally, before we go, we need to go into this create table sync and check and make sure that we have the right what's the name, the right unique what's the name that we created. So the unique constraints that we created earlier, so we need to do the same here. So we need to create unique constraint here. No, not for the sensor MSF, for create average value per sensor type. Yeah, so we need to create this constraint automatically, so we don't have to do it again. So just add the constraint of sensor here. So we do the same for the count as well. Yeah, that's all we need to do for the two. Yeah, for the count per sensor, we're typing sensor type unique. So this is going to be unique 1. Yeah, otherwise it's going to throw an error message like it already exists. Yeah, that's fine. And I'll just stop the completion. So let me just double check this average value. Yeah, that's all we need to do here. So we'll try to execute that. Okay, good. So let's try to package this and run and take everything for a spin. I hope everything works just fine and we don't have to keep debugging this. If not, we have to check each time where the error is coming from. So let's see what that looks like. So just here, I'll just clear this up, and on my Flink dashboard, I still have 20 task slots for my data. And if you look at my Neon console here, I don't have anything created here. So by the time I start my Flink job, so let's have Maven package, okay. So it says, oh yeah, I'm in the runt directory. Just close this and create a new terminal. So it just it goes back to the right. Yeah, so I just have Maven package. So it's scanning for the project and trying to package everything. Okay, the build is successful, and so if I type in which Flink, my Flink is still linked to the same directory that I have. So I just make sure I added this bin directory into my path. So you might need to do the same, so you can be able to run your Flink directly. So I just run the Flink run target Flink decodable MSF, and let's see what that looks like on the dashboard. So it's submitting that. Hopefully everything is fine. Yeah, job submitted, and let's see what that looks like on the UI. So this is what the UI actually looks like. So we have, looking at this, we have all these Kinesis from temperature, from humidity, and the energy source all connecting to this filter, which is this guy. So this field, for some reason, which I don't know yet, and we're going to look at why in a moment. So it connects to that, and we have a tumbling window right into the JDBC sync, another one into for the count %. So good. Let's look at the exception and see what that looks like. So it says sensor type unique already exists. So I thought I take care of that. I took care of that already. So create table sync. sensor type unique, sensor type unique 1. Did I not save this? Yeah, okay. So I think it was because of the if you can recall, when I was working with Neon earlier, I created a unique constraint for one of the tables that I created with that. So this is going to fail, obviously. So I need to just stop this. It has tried 5 times and it failed. So let's, if you look at this, it failed. That's the exception here. So it stopped this by the maximum number of retries. So it's okay. So let's repackage this. Maven package and Flink run target Flink decodable snapshot. I will try to run this and package it again and see what that looks like. Oh, by the way, the table should have been created by now because we added it to the anchor for the creation. So only the ones that are left. Yeah, you can see we have the average value per sensor, count per sensor, then sensor data, even though there's no data written into that yet. Yeah, so we are seeing as data as expected. Good. So the create stable sync is anchored into the establishing the connection. So before it tries to run those queries, I just try to submit, create those tables automatically because we're using this rich table sync for the creation of the tables. Okay, and if you look at where we have it just above here before everything starts. Okay, and going back here, so it looks like the job is submitted, and here on the dashboard, this is the running jobs. Did it fails again? Let's see, any exception. Unique type 2 already exists. So okay, so what can we do? So if you look at the I think I might need to remove those from there. So I was thinking I could do it once and for all, but I just realized that each time this runs, it tries to create a unique constraint every now and then, unlike the tables that use if not exist. I'm not sure in Postgres if you can use if not exist, so I'll just comment those out for now. So it's trying to resubmit the job, and let's see what that looks like. Yeah, so everything is trying to initialize now. Hopefully, yeah, everything is running without errors now. Good. So yeah. So is there any back pressured or busy? Yeah, everything is fine. Yeah, it looks like everything is okay. So let's see if everything is fine. Hopefully. So if you look at the Neon table, we are not seeing any data yet. So let's try to publish some records into that and push. So this is going to trim the horizon and start pushing data into this. So let's see. Yeah, we can see the data is writing now, and the data that I've been reading since are now automatically coming into the picture here. And let's see, everything on the dashboard is still fine, isn't it? Yeah, 42 records is coming in. Yeah, as expected, as it is, everything is coming in from there. But we're seeing only temperature, so we should be seeing all the data, not only temperature. So did I do anything to this? Yeah, it looks like they are getting delayed, so probably temperature gets there first. The rest will be coming in shortly. So let's see the devices average for this count per sensor type. These guys have not started the aggregation, but I believe they will still be coming in. We just wait a few seconds for this to start coming in and for the aggregation to also start. So there's an error here when writing the average. Yeah, that's probably why that wasn't done. So it says running longer on the task executor. So it's taking some longer time to run. So it tries to restart it because of the restart strategy that we added to the system. Hopefully that's taken care of. Yeah, I'll just take a pause and see what that looks like. Now, because I don't have much resources on my laptop, that's probably why some of this is failing. So let's see. Only temperature is even coming from here. So yeah, but regardless, you can see that the data is getting written here. I'll just try to submit this to MSF where we have enough resources to handle all of this data. Okay. Yeah, that should take care of everything. At least we know the data that is coming from 22 here. The 3 of them is getting written, 66 of them is getting written here. So that's good. So let's cancel this. Let's cancel this and try to submit this to our Flink cluster. So let's create on Amazon Kinesis. We create a So we go to Kinesis Analytics here. So we've taken care of the streams. So we just need to go to the analytics part where we create a managed service for Apache Flink. So you can just find MSF here. So which is the manage Apache Flink. So that's the MSF. And we just create a streaming application from here. So by creating a stream application, don't forget I already created an S3 bucket here. And here I have a job that I was using. So I'll just delete this job. To demonstrate this properly, I delete this. Okay, so now I can upload the latest jar file from here. From our guy here, I'll just upload this jar, and in the targets, Flink decodable, this guy, open in the Finder, and here when I'm uploading, yeah, I'll just drag this here for the upload. Yeah, once I drag it here and upload. Okay, so now that the upload is done, I close this up, then we are ready to create our Kinesis analytics. So the first thing you want to do is, if you don't have one, you can just go to Kinesis here or anywhere in AWS services. You can search for Kinesis or MSF, that's Manage Apache Flink Service. So this is going to load up this particular web page, and you can create a streaming application. So with this, you already have a Java file that can work for our use case, and the version is 1.19, so which is good. So the application name is going to be Flink Decodable MSF. So if there's an alarm row, it uses that. If there's none, it creates one for us. So we can roll back production, everything is as it is. So we just create application. So once we do that, we have this UI that is presented to us. So we can now link our Java file to this, and clicking on that, we're using the current Apache Flink runtime. You can change it if you want, but we're going to stick to 1.19. And for the Flink location, for the Java file location, I'll select this guy, and it goes into this S3 Flink app. Now, where the path is exactly, I'm just going to copy the S3 URI and paste it here. Remove the Flink app from here, and that's it. Now, this is the path to the S3 to the Java file, and we have this as it is. Nothing else is changing. Let's see. You can change the scaling if you want any parallelism, so I'll leave it as it is. Okay, info one, no VPC, that's good. Yeah, I'll just save the changes and we wait for that. Okay, so the application is created successfully. Now the next thing will be to run this. But before we do that, let's verify if the required access is added to the policies and roles are added to this permissions are added to this rule in itself. So I just click on that, and yeah, I have Kinesis Analytics, full access, Kinesis, and S3. Just in case you don't have these three added to it, don't forget to attach this to each of them. Once that is created, yeah, so the next thing will be to run this up, and let's see what that looks like. Okay, I'll just click on run, run with the latest snapshot, and run. So it takes a few seconds. Hopefully, if everything is fine and there's no errors, this should start up fairly quick and easy. So it's starting up now. We just wait for that to be done. Okay, so application has been successfully started and is currently running. So the next thing will be to now check what this looks like on the UI. So I'm just going to go into the code again and try to push some data into the stream, and let's see if everything gets read from there and then pushed into the DB. So I'm just going to open the Apache Flink dashboard, and we can see if everything is fine on this dashboard. Okay, so yeah, so this is what it looks like. Yeah, so the same structure we had on our local system is the same here, and yeah, so you can see some data being sent across from each of these activity into the end, and let's see if everything is as expected. So I just need to go into my Neon console and see if maybe I should just truncate the records here. I think we're done with the MSF there. Yeah, we can just see if the new records are populated into that. Okay, count per person, count average value. I'll just try to truncate both. Okay, good. So we just wait for this to pick up. Yeah, so something has failed here. So there's an exception. So let's see what this looks like. So it's saying, yeah, so it says checkpoint, blah, blah, blah. Writing JDBC records failed. So it says it's trying to do inserting to count per sensor into this on conflict. So, well, because it couldn't have updates, this and that, value too long for the character varying. So yeah, so there's an error in that in this column. So let's quickly fix this for this count and average. So if you go to the SQL editor, so I'll just alter table. Let's get the table name from here. Yeah, count per sensor. I'll just go back here, alter table, then alter column. Count per yeah, alter table this, and then what column is that? So that's the sensor type, isn't it? So let's just increase that to, let's say 50. Okay, varchar 50. Okay, so that should yeah, type varchar 50, and then we do the same for the average as well. Average, I'm not sure of the name, let's check. So that's AVG value per sensor type. Okay, so AVG value sensor type. I'll do the same for that, and that should fix both of them. So let's just wait for this guy to get restarted, and so it just restarted again, and that should you know, start pushing data into the DB. Okay, so everything seems to be running. And are we still producing? Okay, we're still producing. Good. So data is getting sent into this guy. Do we have any data here now? Yeah, so data is getting produced to the sinks, and so we just need to wait for this other sink as well to pick up the task. Yeah, let's check it out. On Neon console, I just need to go to the tables, and yeah, you can see temperature is dropping. Temperature is also dropping here as well, and here temperature is dropping. But interestingly, the other sensors are not writing to this db. So let's see if I can quickly fix that. So yeah, if you look at the data stream job, I have my temp source here, and the temp source is the only one that is connected to the rest. So if you look at the temperature data stream, so humidity data stream as well is connected. So but instead of this, it should be humidity source. You probably saw that part. Yeah, but I'll just yeah, I'll just need to package this again, and the three should maybe package. Once that is packaged, I'm just going to take a pause on this. Just pause there, don't worry. Take a pause, and yeah. So I mean, I'm not sure how I missed this part, but it's just the only temp source that was replicable, maybe because I copy pasted it. So for the humidity data source, so you need to be careful of this error as well. So I wasn't sure. Well, I didn't even notice this part of error was there because of the copy pasting. But regardless, you need to make sure that humidity data source is connected to the source for the stream, for all the other streams as well, and then the energy source. Then the data will get written directly into as expected. So I just need to re-upload this and restart the app. By the way, I think I should just increase the snapshot value. So this should be snapshot 1.0. So let's say this is 1.1. Okay, and I'll just package this up again. Okay, so the packaging is done, and we have a new Java file 1.1. I'm just going to upload this into MSF S3 bucket, and yeah, I'll just yeah, I need to go to the upload this guy, and upload this guy into this place and upload. Okay, so now that it's fully uploaded, I just need to go back here. So I have the two snapshots here. I go back to the configuration again, and then change the snapshot. So I'm just going to change this to 1.1, and that would be the, yeah, I'll just leave that to it and save changes. Yeah, this is still having the exceptions, and some of them are, yeah, so they're still failing. So I'm just going to stop that other one that was running. Hopefully that should be automatically stopped, but if not, I'm just going to stop that. Okay, so now going back to the configure, let's see if that is applied now. So that's 1.0, still 1.0. Just change that to 1.1 and save changes. Okay, so that is updated. Now we have the 1.1 version as the snapshot. So I can just have this run. I'll just click on the run again, the latest snapshot, and run this. Okay, so the application is started with a new version, and then let's check what that looks like on the dashboard. So on the Flink dashboard that is created by MSF, you see something like this. Still Flink Java API. You can always change this later if you like. So hopefully this should be fixed now, and all the data should be running as expected. Okay, so I'm just going to try and rerun this and try and produce some data into that. So some new data and records can be activated once that is done. Okay, and that is producing now. Yeah, it is. So this should be picking up these streams and writing them to Neon console on the DB. So I'll just go to the latest records here. Maybe I just truncate all of this. Yeah, truncate this. All right. So we can just wait for new records to be coming in. And as expected, you can see the latest records for energy, humidity, temperature, all coming in as expected. So here you can see the 3 data coming in as expected. I already deleted some of them, but it doesn't really matter. This is just like to show you our possibilities. So if you prefer, you can always truncate everything and start from the scratch. Or delete the table, recreate a new one, and you always start from the scratch. But regardless, this is how you can write and push stream data into Apache Flink MSF, and it writes into like your JDBC sync on the cloud. Well, yeah, this is not running on my system as it is right now. All I need to do is write the code on my system, package it up, ship it to MSF, and then everything starts running. On the contrary, with Decodable, all you just have to do is connect to your source, connect to your sink, and write your transformation logic in between. Then create a pipeline to join your sink to the transformation, then transformation to the sink. That's all you need to do. And one other thing that is another strength of Decodable is when you have multiple data sources in the sink that you want to add to that, you don't need to rewrite your code or repackage your code and start everything with a new snapshot. All you just have to do is connect to a new sink and link to the existing streams, and that's it. Automatically it gets picked up. If you want to start at the earliest time or the latest time, you just start shipping data into that. Now let's talk a little bit about some of the resources that is available for you to use on Decodable. So the first is, what you want to do is go to docs.decodable.co, and on this page you see some of the resources that you have in here. So you can get started with Decodable for free without the use of any credit card. So there are some quick starts you can use, some of the examples that you can also work with. You can see how you can start with Decodable in just having your connector, your pipeline, your stream, and all that. But regardless of that, once you go to the quick the getting started, you see the quick start, setting up a Decodable account, some of the checklists that you need to do. And now you can connect to the sources and the destination, managing of the streams, the pipeline, everything here, and how you can administer this as well, and maybe setting up your team, monitoring and stuff like that. So all this information is in a central location called docs.decodable.co. I'm going to leave the link in the description below for you to use, and you can just take a spin on this. And on the top right hand corner, you can see the community Slack. So in this community Slack, you can join the Slack community here, and it's going to direct you to the Decodable community. I already joined the community, so there's no need for us to go into that. But once you go into the community Slack on the top right hand corner of the screen, you'll be able to join the community, and you can ask whatever questions you have that is specific to your use case. And most of the general challenges you're going to be facing are already covered in these docs. And you can see some of the APIs that is available for you to connect to if you are using the API plane for the communication and facilitating everything. So there's a SDK that you can also use, so you can also build and run your Apache Flink jobs. So that information will be left in the description of this video below, so you can go to some of those resources to get help. And if you get stuck at any point in time, or you need some help that is specific to this video, you can just send me some of the comments in this in the comment description. I'll be more than happy to respond. Also, you can join me on the Decodable community, and I'll be active there as well, answering some of the questions that is pertaining to some of the things we discussed in this video. Okay, thank you very much for watching, and I'll see you in the next one.